Okay, we're in section 22 of the notes. This is the section on radical equations. We covered this material, hopefully understood that it was presented to you. You studied the material, and now you're ready to do it on your own. What I mean by that, you're ready to do the assignment that's embedded in the notes. We went through a bunch of examples. Again, for those students that need additional support, there's videos on the side. You can watch those spot videos if it helps. If it doesn't help, try to find some alternative that does help in dealing with these problems that we give you. All right, there wasn't many questions to go through. Now, when I go through the homework, the expectation is you've studied the material and you've done the homework. Now, when I switch to the whiteboard, the notes are going to disappear. I'm hoping that you have the notes in front of you along with your solutions that you've worked on, the work that you've done for these problems. All right, it's important you do work. So I'm going to change to a different screen share. Just give me a second. I'll install a plugin now. All right, give me 1 minute. Okay, blank sheet of paper. I just have to find my pen now. And sure, it's over here somewhere. Yep, I found it. So again, you're seeing a whiteboard now. You're not seeing the notes. The notes should be in your possession now. We're in section 22. And we're doing the homework. Problem number 1. What does it say solve? I'm going to write this down for you. It's a radical equation. The radical is a square root. And what does it say? It's the square root of 3x plus 1 is equal to 4. What we recommend you do is isolate the radical. Well, the radical is isolated. It's alone on one side. This is the radical. It's alone on one side. So it's isolated. So our recommendation, if it's isolated, what you're going to do is raise both sides to some integer power. The integer that we recommend is the index of the radical. Well, the index here is a square root, is a 2. So we're going to square both sides. What's nice about that? Well, on the left side, you just get 3x plus 1. On the right side, you get 16. Now, what are we going to do? Subtract 1 from both sides. And what do you get? 3x equals 15. Then I'm going to divide both sides by 3. And what do you get? You get x equals 5. Now, certainly it may be premature, but I can put a box in this indicating that's the solution I arrived at. I want to see if it's correct, though, so I want to check it. In the original, this is the original. What do I believe? I believe x is 5. Well, if x is 5, what do you get? 3 times 5, which is 15. And 15 plus 1 is 16. And certainly the square root of 16 is 4. This works out beautifully. I also want to recommend you look at the answer key to make sure you're staring at x equals 5. And you are. All right, let's go to number 2. Again, if this is going too quickly for you, my suspicion is you haven't studied and done the homework yet. And you should do that. All right, you really need to do that. Certainly come back at the end of the week and watch these if you like. They'll be published online. So what's number 2? It's a radical equation. I'm seeing the radical. Well, first thing I do is I have to isolate the radical. That means get it alone on one side. So I got to get rid of this guy over here. The way I do that is I'm just going to simply add 5 to both sides. And what would you get? Well, if you did that, you would get the root of x minus 5 is equal to 5. Well, now the radical is isolated. It's alone on one side. So what's our recommendation? Raise both sides of the equation to the index. And what's the index? It's a square root, so it's a 2. What do you get? Something pretty simple. X minus 5 equals 25. I'm going to add 5 to both sides now. And what do you get? You get x equals 30. Again, it may be premature to put a box on it. but I want to put a box on it so I can check it. So what do you get over here? Go back to the original. Again, I want to point out this is the original, and I want to check it there. Let's see if it's 30. What would you get? The square root, 30 minus 5 is 25, minus 5 equals 0. Square root of 25 is 5, and 5 minus 5 is, of course, is 0. I'd also recommend looking at the answer key to make sure they said the answer was 30, and it is. All right, let's go to number 3. And number 3, it's a cube root problem. It's still a radical, though. And it's 6x equals minus 3. Well, again, first step, isolate the radical. It is isolated. What's my next step? Raise both sides of the equation to the index. And what's the index? It's 3. So what do you get? Well, something pretty simple. You get 6x on the left side, and minus 3 cubed is minus 27. What am I going to do now? Divide both sides by 6. And what do you get? X equals, you should reduce it. And what has it reduced by 3? So what do you get? Let's see, 3 goes into 27 9 times, and it goes into 6 2 times. Again, it may be premature to say that's the answer. I'm still going to check it. How do you check it? In the original. All right, so let me just write down the check for you. And put check over here. The original was a cube root of 6 times, well, I believe it's minus 9 over 2. And they said that should be equal to minus 3. This is the original equation. I was plugging in x equals minus 9 halves. What do you get? Cube root. I've got to simplify that. Well, 2 goes into 6 3 times, and 3 times minus 9 is minus 27. And the cube root of minus 27 certainly is minus 3. This worked out well. Again, I want to recommend look at the answer key to make sure you're staring at that. And I am. It says minus 9 halves. All right, let's go to number 4. Again, relatively simple questions that are in line with what we presented to you in class. All right. So I'm going to go to number 4. And that's a fourth root problem. It's the fourth root of 4x plus 5 is equal to 3. Again, our recommendation, isolate the radical. It's already isolated. And then raise both sides to the index. What's the index for? What do you get? Something pretty simple. 4x plus 5 equals, well, 3 to the 4th. Again, 3 times 3 is 9, times 3 is 27, times 3 is 81. Subtract 5 from both sides. You can get 4x equals, whoops, sorry about that. I made an extraneous thing. I'll get my eraser out. And that's going to be what? 76, right? Divide both sides by 4. And what do you get? X. I have to reduce that, right? Well, let's see. I'm going to say die 2 first. And 2 goes into 4 twice, into 76, 35, 38 times. And then 2 goes into 38, 19 times. All right, what am I going to do? I'm going to recommend you check it. All right, fourth root. I say it's equal to 3. 19, 4 times 19 is 40. And 36, 76. And 76 plus 5 is 81. And the fourth root of 81, in fact, is 3. All right, so it's worked out well. Again, I'd recommend you still look at the key to make sure they say x equals 19. Now we go to number 5. This is substantially more difficult for students. And unfortunately, a lot of students, they get a wrong answer and they don't check it. And then they wonder why they're graded wrong on it. Well, we're trying to really emphasize steps that you should take in the problem like this. So I'll write down the original problem. And there's 2 radicals here. It's still a radical equation. My recommendation is to isolate one of those radicals. Well, to do that, I would say to isolate one of the radicals, I could subtract the root of x minus 3 from both sides. And what would you end up with? The root of x plus 1 equals 2 minus the root of x minus 3. Now someone says, what did you just do? I isolated one of the radicals. What's your recommendation now? Raise both sides to the index, which is 2. Now, the left side's really easy to do. The right side may be more difficult. I'll write it down for you. You should be in no rush to an answer. I know this is difficult. We're encouraging work though. 2 times 2 is 4, minus 2 root x minus 3. I'm using the distributive property of multiplication. Minus 2 root x minus 3, and then plus x minus 3. Yeah, looks complicated. X plus 1. Let's see. I'm seeing things. I want to tell you what I'm seeing. I'm seeing the 4, and I'm seeing minus 3. That would give me 1. All right. What else do I see? Plus x. I'm going to point that out to you right over here. All right. What else do I see? I see these two guys. And what's that going to give me? Minus 4 root x minus 3. All right, someone says, what are you doing now? I'm still doing the same thing over and over again, isolating a radical. How would I do that? Subtract x from both sides and subtract 1 from both sides. What do you get? 0 equals minus 4 root x minus 3. All right, let's keep going. I know it's difficult. We're trying to encourage you to move forward now. I'm going to divide both sides by minus 4. Because again, I'm trying to isolate that radical. What do you get? 0 equals the root x minus 3. What are you going to do now? Well, I've isolated the radical. I'm going to raise both sides of the equation to the index, which is 2. 0 squared, 0 squared is 0. And the right side when you square it is x minus 3. What's x? X is 3. All right, I want to go back and check it. Now I'm checking in the original. And I'll put out what the original is. The original is this over here. I believe x is 3. So what do you get? Root 4 plus root 0 equals 2. Well, root of 4 is 2. The root of 0 is 0. And this does make sense. I want to also recommend you look at the answer key to make sure you can agree with that. And the answer key does say 3. All right, x is 3. Let's go to the next question, which is number 6. Number 6, I notice it has a lot of work. All right, someone says, why do you put the work down? A student asked me to put the work down. That's why I put the work down. But let me write this over here, 6. And this is a radical equation. And my recommendation is to isolate a radical. All right. Now what I'm going to do over here is I'm going to subtract away the root of x minus 5 from both sides. I'm sorry, x plus 5. The root of x plus 5. What would you end up with? Okay. Here's what I'm going to emphasize over here. This radical is isolated. Right. This one's not, by the way, but this one is. I've got a radical isolated. What's our recommendation? Raise both sides to the index. And what do you get? You would get 3x plus 4 on the left side. On the right side, I want to point out what you're looking at is 7 minus the root of x plus 5 times 7 minus the root of x plus 5. Let's keep going. Don't be discouraged. 7 times 7 is 49. Minus 7 root x plus 5. We're using the distributive property of multiplication. And my son's mind is a positive. All right. A lot of work. I know that. 49 plus 5. Whoops, sorry about that. My little eraser out. I want to point out what I'm doing over here. I'm looking at this and this. I'm going to add that together, and 49 and 5 is going to be 54. Plus x minus 14 root x plus 5. All right, got to keep going. I'm going to subtract 54 from both sides, and I'm going to subtract x from both sides. All right, what do you get over there? 2x minus, right, 50 equals minus 14 root x plus 5. Yeah, it looks kind of nightmarish, doesn't it? So what I'm going to claim to do over here is, and again, your mileage may vary. You may say, I don't want to do that. I want to do something different. We like seeing people do things differently. We really do. Of course, if your idea of different is I'm not going to do it, that's not a different. You want to do something. What I'm going to do is I'm going to divide both sides by minus 2 and write this down for you. Someone says, why would you do that? Well, it's common between those, terms I'm looking at. 2, that's 2x actually, 50, and then the minus 14. And what'd you get over there? I'll write it down for you. You would get 25 minus x on the left side. On the right side, you would get 7 root x plus 5. Now, the radical's not isolated. So what I'm going to do is I'm going to just simply raise both sides to 2, even though it's not isolated. And what do you get there? 25 squared. I'll write that down for you. Minus, I'm getting better at this. I'm going to say minus 50x plus x squared. What do you get on the right side? 7 squared, 49, and x plus 5 squared. I'm sorry, the root of x plus 5 squared is just x plus 5. All right, let's keep going. Again, I know it's difficult. X squared minus 50x plus 25 squared. We'll do that later. 49x, and then you can get a what? 49 times 5, right? Okay, let's keep going. And kind of looking at it, I'm going to subtract 49x from both sides. Yeah, I know it's a lot of work, right? And I'm going to subtract 49 times 5 from both sides. All right, what do you get? X squared minus 99x equals 0. I got some arithmetic to do, don't I? Let's put this down the side for you. I'm going to put 25 squared down for you. What's 25 squared? It's 25 times 25. Again, the way I do arithmetic, the way you do arithmetic is incidental, but the outcome should agree. So I'm going to say, 2 times 25 is 50, so 500. Then 125, 625. All right? Let me get my little eraser out. And I know I got 625. Now, what's 5 times 49? That would be, let's see, 5 times 4. Well, that's going to be, it's really 40, 245. So I'll put this over here, 245. All right? Again, I hope I'm not too exhausted on that, but it's really not that bad. I'm going to do some subtraction now. All right, what do you get? 0. All right, this is going to borrow 5. This becomes 12. This becomes 8. This becomes 3, 380. Put this over here. And plus 380. Yeah, it's tough. It's long too. Don't be discouraged though. So what are you going to do now? Well, I'm going to try to factor it. And someone says, do you think that's factorable? It will be awful if it wasn't. So x and x, I'm going to say it looks like 95. I know it's tough. And 4 might take you some time to get there. Minus, minus. Let's just check it out. You get x squared minus 99x. Does work. And you get plus 380. So we get x equals 4 or x equals 95. Again, it would be premature for me to tell you that's the correct answer. I want to go back to the original statement, though, which is this over here. I'm going to try it out. I'm going to try this one first. I'll see if it works out. I don't know if it works. So what do you get? 9. And what do you get there? Let's take a look. 3 times 4 is 12. 12 plus 4 is 16. And I wonder, does that equal 7? I don't know. 3 plus 4. It does equal 7. So that's a good answer. I'm going to try this one. I don't know. Maybe it does work. Let's put it over here. What do you get? 100. That's not so bad. Plus, well, let's see, 95 times 3 270, 285, 289. I don't know. 100, square root of 100 is 10. Square root of 289. Wow. What would that be? 289. Right? Maybe you want to take your calculator for that. I don't know. Let's take a look. Let's see. 289. Ready for this? Is it a square root? To be honest with you, I don't really think I even need to know what that square root is. I'll tell you why. It's a positive number, and there's no way it would ever equal up to 17. So I'm going to say this is extraneous. It doesn't work out. There's only one answer. All right. So here's the deal. So I'm going to, again, look at the key, and I want to make sure that they also agree with that. And looking at it, it does say the answer is only 4, but it does go on to say the solution gives you 495. The work is all down there for you. All right, I'm going to call it quits on this, and we'll go back to another share. Just give me 1 second to do that. And we're now at the related Sage code. So I just want to go, again, to indicate what you do is you click on this. It'll open up a web browser if your machines are properly configured. If not, you open up a web browser and type that sagemath.org in. Go to CoCalc. We've been doing this many, many times. It's optional. No, you don't have to. We're not going to test you on it. However, if you plan to move forward, whether it's at Essex County College or another institution, you're going to have to learn how to use a computer, particularly to do difficult problems. Of course, these are problems that we do by hand. We've been doing this for some time. Remember, I like new sheets. I want to do a Sage worksheet. And just give it a second to load. So it's a little bit slow. And we're going to be typing this code in. All right. So reset. We've been doing this for some time. Shift return. X is a variable. We've been doing this for a long time too, haven't we? And we've been solving equations. What's this? Square root. All right. And again, I'm just simply copying what I'm seeing in the piece of paper here. 2 minus x. Remember, equations have 2 equal signs in it. Equals 4. And we want to try to solve that for x. Remember, shift return. All right. Machine's warming up. You see it's working. Oh, there it goes, minus 14. All right. Could we have done that by hand? We did. In fact, we did it by hand. If you want, you can copy paste these in as well. But for the most part, we're just trying to get your feet wet in programming. You may wonder what the coding is over here. It's Python. All right. Thank you.